We're going to be starting paper 1, May-June 2003. This is a 2-hour paper and calculators are not allowed for this. So let's begin. Okay, let's start with question number 1. Express 0.03 as a fraction. So this would be as a fraction. If we want to convert 3 into that, we would divide it by 100, right? And just to make sure, when you divide something by 100, you basically move the decimal by the number of zeros forward. So in this case, there's 2 zeros, so that's 1 and 2. And the decimal would be here, so this would become 0.03. That means 3 over 100 is actually 0.03, and that is what it is in a fraction. All right, express 150 as a percentage of 500. So when we want to take a percentage of something, we just put the numbers on top of each other and multiply that by 100, because we're trying to scale it to 100 to see how much it would be as a percentage, how much 150 would be as a percentage of 500. So we can simply cross out these zeros. That means we just have 150 multiplied by 1 divided by 5. And that is just 150 divided by 5, which is 5 3s are 15 and a 0. So that's going to be 30%. And that is question number 1. All right, moving to question number 2. Okay, so question number 2 is evaluate 7 over 8 minus 7 over 10, giving your answer as a fraction in its lowest terms. All right, so if we're minusing two fractions from each other, their denominator or their bases need to be the same. So for that, we can basically figure out what's the lowest common multiple of 10 and 8. That would be 40. Right? So now that we have 40, we can figure out, okay, how do we turn 8 into 40 and how do we turn 10 into 40? So we can multiply 8 by 5 and we can multiply 10 by 4. And when we do that, we have to multiply the top part by 5 too. So 7 5s are 35 and 7 4s are 28, right? So that becomes 35 minus 28 over 40. So now the denominator is the same, and 35 minus 28 is 7, so we get 7 over 40. And I don't think that it can be reduced any further, actually. So that is the answer. All right, and then B is evaluate this, this multiplied by this, giving your answer as a mixed number. All right, so first I'm going to convert these mixed numbers back into mixed fractions, right? So that back into like just fractions. Sorry, right now this is a mixed fraction and I need to convert it into just a normal fraction. So to do that, we take the wholes and we multiply it by the denominator and then add it to what's up there. So 3 2s are 6 plus 1, that is 7 over 3. This would make 2 wholes 1/3, multiplied by 2 3s are 6 plus 1, that is 7 over 2. And now when we're multiplying fractions like this, we just multiply this with this and this with this. So 7 into 7 is 49 and 3 into 2 is 6. And now we need to give the answer as a mixed number. So 6 6 are 36, 6 7s are 42, 6 8s are 48, right? So 8 wholes and then 1 over 6. And I think that is the answer, 8 wholes, 1 over 6. Cool. And let's also do part 3, or rather question number 3. So that is 24 divided by 6 plus 2 into 9. So for this, we follow the method of PEMDAS, which is parentheses. People also use BODMAS, which is the same thing. This is just a different way of saying it. So parentheses, exponents, so x to the power of 1, we would do that first. And then multiplication and division are basically, you can do them at the same time. So you put them on the same level, multiplication, division, and then addition, subtraction. So that's the order that we follow. It's the same as BODMAS. If you're doing BODMAS, that's completely okay too. So with that, let's do multiplication first. 2 9s are 18. Plus 6, 24 divided by 6 is 4 6 are 24. So we do 4 plus 18 is 22. Perfect. And then we'll also have 0.4 into 0.02, which is 4 over 10 into 2 over 100, right? And then now we know from the question before that when we have fractions, we can just multiply the top and the bottom. So 4 2s are 8. 4 2s are 8, and 10 into 100 is just 100 with another 0 at the end. So that is gonna, and then we can take the decimal 3 forward. So 1, 2, 3. So that's gonna be bloop, 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 bloop. It's gonna be here. So that's gonna be 0.008. And that's our answer. Okay, moving on to question number 4. Local time in Singapore is 11 hours ahead of Trinidad. Look at the two clocks in the answer space. One shows the local time in Singapore, show the local time in Trinidad on the other clock. So if it was 12 hours ahead, it would be here, right? The hour hand, which is this one, would be right here if it was 12 hours ahead. So it would actually be, instead of being 7:35, it would be 8:35. But because it is 11 hours ahead, it is just one behind there. So if it's 8:35 currently in, so that's 8. That's 8, and then the minute hand doesn't change. If that's 8:35, and then if we go 11 hours ahead of that, we get 7:35, but in the evening. So I think that is the time in Trinidad. If that doesn't make sense, please comment, and I'll explain it further. But basically, it's just 11 hours is actually just 1 minus 12 hours. Okay, so it is 9:15 a.m. in Trinidad. Using a 24-hour clock, write down the local time in Singapore. So to do that again, if it's 9:15 in Trinidad, if it's 9:15, all we need to do is take it 1 hour back and then 24 hours ahead, because it's 11 hours ahead, right? So 1 hour back to have it be 8:15, but because it's AM, hold up, which one is Trinidad? The one that's forward? Singapore is 11 hours ahead of Trinidad, right? So if it's 9:15 a.m., 11 hours ahead from that would actually be 8:15 p.m., right? Yeah, no, this is 11 hours behind. I guess it doesn't make sense. It doesn't matter because it would be 8:15 p.m. regardless. But either way, 8:15 p.m. in Singapore. But because they're asking for a 24-hour clock, if you have a p.m., all you have to do is add that amount to 12. So you get 20, 15, and then you don't need the p.m. because a 24-hour clock, the numbers tell you what the AM or the PM is. So the answer would simply be 2015. All right, time to factorize this. So to factorize that, all I need to do is break up the middle term into two terms that will add up to make this, add up to make that, and then both of those terms need to multiply together to make 12. So I need to come up with these two terms, and I think these two terms would be -3 and -4. There are multiple methods of figuring this out, and I'll probably make a video about factorization. But for the most part, you take the middle term and you break it into two terms that add up to make the middle term again, and multiply to make this term. So with that being said, these two, they multiply to make 12, and they add up to make -7, because that is a minus there. All right, so if we now write this as -3x minus 4x plus 12, we can now factorize by taking x common here, so x minus 3, and then we can take -4 common, x minus 3 again, and then that is going to make our factorization to be x minus 4 and x minus 3. And we can go and write that into our answer space. Always remember to write these into an answer space. I don't know, these are pretty old papers, they're like 20 years old, so I don't know how answer spaces work right now, but either way, just remember to fill these out, otherwise you don't get credit. Alright, part B. So part B is solve x plus 1, so these are already factorized. 3x minus 2. So when they're already factorized, we can take both of the factors and essentially we can do this. This is because this x, basically this is a polynomial, which means x is going to have two solutions, right? When you put this on a graph, it would look something like this, or there's different variations. You don't need to go into it currently, but it would look something like this. That means there would be 2 points where where y would be 0 and x might have some two different values. If like this is y would be 0, and then there's 2 points where x would have different values, and that's what we're essentially doing. So when we factorize, we say this is a factor, so this might be one value of x, and this might be another value of x, and those are the two factors of our graph. So that's why we will have two solutions here, and we can take those two factors and we can equal them to 0 for these two equations that we can solve to get the two values of x. So one of them is x minus 1, and the other one we can subtract 2 from both sides. That makes 3x. Rather, we add 2 on both sides, because 2, we need to add 2 here. It means 3x over 2, and then we divide both sides by 3. That gives us 2 over 3. So x is equal to minus 1 or 2 over 3. And that's our answer. So moving on, let's do question number 6. Express 99 as a product of its prime factors. So what we really need to do is we just need to divide 99 over and over by some prime numbers, whatever prime numbers it gets divided by easily. And when we have those divisions, we can multiply those together and it makes 99 again, which means we have the prime numbers that basically form a product that makes 99, and that's how we'll express 99. So in theory, in practice, how I would do this is I place this, and then 99, the first prime number this gets divided by is 3, so that makes 33. The first prime number this gets divided by is also 3, that makes it 11. 11 itself is a prime number, so 99 expressed as a product of its prime is 3 into 3 into 11, or simply 3 squared times 11. So that would be 3 squared times 11. And then find the smallest possible number or integer value of n for which 99n is a multiple of 24. So 99n needs to be divisible by 24 so that this gets crossed out, and like this would be a whole number and that gets crossed out, and then we get left with something, whatever that is, right? So to do that, we need to find an n. So since we already know 3 squared times 11 is 99, we need to find out what 24 is. To find out what 24 is, and 24, so the first one that gets divided by is 2, so that makes 12, another is 2, so 6, then another, that's a 3, and then a 3, and that would be a 1. Let me do this over here, and let me do this again. So 24, so 2 divided by 2, it gives us 12, another 2 gives us 6, another 2 gives us 3, and then a 3 gives us 1, and we don't need to include 1 because it is implied that that would be a factor, but 1 also, I don't think 1 counts as a prime number, but I'm not fully sure. But anyway, so 24 is actually 2 to the power of 3 times 3, right? So we have 3 to the power of 2 multiplied by 11 multiplied by n divided by 2 to the power of 3 times 3. So 3 can actually be divided, right? But we still have in the denominator a 2 to the power of 3. So n quite possibly needs to be 2 to the power of 3 so that when we do this division again, so if we make n 2 to the power of 3, we would have 3 to the power of 2 multiplied by 11 multiplied by 2 to the power of 3, and then that gets divided by 2 to the power of 3 multiplied by 3. So this 3 takes a power away from this 3, so that becomes 3, and then this cuts this out, so the answer would be 3 into 11, which is 33 when we divide it when we have our n. So that means our n should be 2 to the power of 3, which is 8. And remember, we're trying to find the possible value of n, we're not trying to find the possible division. So even though I divided it out, it wasn't needed to be divided out. All we needed to know was that n is equal to 2 to the power of 3, and that lets us do our division successfully. So, and 2 to the power of 3 is 8. 2 to the power of 3 is 8. Because 2 squared is 4, and 4 multiplied by 2 is 8. All right, hope you were able to understand that. But anyways, let's continue. It is given that 5 to the power of minus 2 into 5 to the power of k is equal to 1. So 1 can also be written as 5 to the power of 0, right? So then what we can do is we can do 5 to the power of minus 2, 5 to the power of k is equal to 5 to the power of 0. And now that all our bases are the same, we can use our property that simply says minus 2, and then when they're being multiplied, the powers are being added. So minus 2 plus k is equal to 0, which means k is equal to 2 if we add 2 on both sides. So k is equal to 2, and then the cube root of 7 is equal to 7m. Now, a cube root of 7 can also be written as 7 to the power of 1 over 3. And now if I write it like this, I think the answer should be fairly clear, which is m is equal to 1 over 3. So within this series, a lot of time it is just, you have to change how things are written, you have to change the way you're looking at things, and then the answer becomes pretty clear. And I think I did this before, but let me do it again. So add 37 kilograms and 40 grams. Give your answer in kilograms. So 1,000 grams is equal to 1 kilogram, right? So if we need to convert any amount of grams into kilograms, all we need to do is divide that value by 1,000. So if we divide 1,000 grams by 1,000, we get 1 kilogram. So if we divide 40 grams by 1,000, we can get rid of the zeros, and then 1, 2, right? So 0.04. So that would be 0.04. Actually, that's not the full answer because we still need to add that together. So 37.04 kilograms. All right, the length of a piece of string is 0.026 meters. Correct to the nearest millimeter. Write down in millimeters the lower bound of this length. So again, 100 centimeters equals 1 meter. And then I think 10 millimeters equals 1 centimeter. So actually we don't really need to know this for this question, since this is already says it's given correct to the nearest millimeter. So this is the nearest millimeter. So we can simply state that these are 26 millimeters. It would be good to know that, but yeah, we don't need it for this question. So this is 26 millimeters. Now for lower and upper bounds, this is a statistical concept, but in terms of like O-level maths, you really need to know that like a lower bound and an upper bound would be half plus this and half minus this. So half plus this would be 24 or 26.5. This would be the upper bound. This would be the upper bound, and then half minus this would be 25.5. which would be the lower bound. So the answer here would be 25.5. I think once we get into more statistical stuff and more things about units, it would be good to clarify like how many millimeters make a meter, how many centimeters make a millimeter. I think it was required for this question, that's why I pointed it out. But since they'd already told us in this question, we didn't really need to know. But you can also just look at this and guess, right? It would be 1,000 millimeters to make 1 meter. Like just looking at that, you can figure that out. But that would be good to know. Also, getting more into statistical knowledge, we would learn more about upper bounds and lower bounds. But for now, for these questions, I think for most O-level mathematics questions, knowing that just using this knowledge, which is not fully correct knowledge, but it applies for these questions, is that an upper bound could be half plus the number and a lower bound would be half minus the number. So make sure to keep that in mind, but I will definitely make videos about statistical stuff and units, mathematics, because these things can get confusing for people. But anyways, let's move on. Here's question number 9. P is equal to 3.2 into 10 to the power of 11, and Q is equal to 8 into 10 to the power of minus 4. So the first thing they want is Q squared, which is this. So we can just write that out fully. So 8 times 8 times 10 times 10. I'm just multiplying it by itself once, and I'm just putting the same numbers together. So 8 by 8 is just 64. And then 10, 10, you can just add these when it's the same number. So it would be 10 to the power of minus 8. And then we can move this decimal one forward, so 6.4 into 10 to the power of minus 7. So when we move it one forward, we can add 1 to this. So 6.4 into 10 to the power of minus 7. All right, now we have P divided by Q. So P is 3.2 into 10 to the power of 11, which we can also rewrite as, so if this is 3.2, if we take 110 out of this, right, so we can also write this as this into 10 to the power of 10, so 3.2 into 10 into 10 to the power of 10, right? If we just solve this out, this would make 32 into 10 to the power of 10, right? So I'm just gonna use 32 into 10 to the power of 10. Okay, and divide that by 8 into 10 to the power of minus 4. Now 8, 2s are 16, 3s are 24, and 4s are 32. So this becomes a 4, and then when two numbers with indices are divided, you actually minus this number from this number. So 10 minus negative 4 is actually going to equal 14. So this will be 4 into 10 to the power of 14. And that is question number 9. So moving on to question 10. So first we have express 2a plus b. So with matrices, when we have a 2a, we're going to multiply both numbers by 2. So this is essentially 2 into 2 for plus whatever b is. So b is minus 3 and 2. So when we multiply both of them by 2, we get minus 4, 8 plus minus 3 and 2. And now adding them, we just add these and keep them at their spot. So adding them together, minus 4 plus minus 3 is minus 7, and 8 plus 2 is 10. So minus 7 and 10 is our first answer. Then our second answer, given that the vector C is parallel to vector A, so A and C are parallel, which means they go in the same direction. Calculate the value of U. So this is U, right? This means that A, when we multiply A by something, let's call it an M, that gives us C. So now we just need to figure out M, right? So M times minus 2 over 4 is equal to U and 10. So we can't do M, so minus 2M is equal to U. We can do that, and we can do 4M is equal to 10. And so M is equal to 10 over 4, which becomes 5 over 2. So minus 2 into 5 over 2 is equal to U, which means U is equal to, so this becomes minus 1, U is equal to minus 5. And let's write that down over there. All right, lastly, we have question 11. We just need to solve these simultaneously. Something that I like to do is I see that this has a 2 and this has a 4, so, and this would be the easiest to solve out. So 4x is equal to, if in the top equation I add y on both sides, y goes away from here, and here we get 9 plus y. Now if I take the second equation and I multiply the entire second equation by 2, I will get 4x minus 6y is equal to negative 46. So now we know what 4x is, so we can just place that in. 9 plus y minus 6y is equal to 46, right? So what I'll probably do is I'll minus, so let's simplify this. We simplify this, we get minus 5y. And then if I minus 9 from both sides, we get minus 55 over here, which means y. If we divide both sides by minus 5, we get y is equal to 11, and then we can just throw that in there. So 4x is equal to 9 plus 11, which means 4x is equal to 20. And divide both sides by 4, we get x is equal to 5. So x is equal to 5 and y is equal to 11. And that's question number 11. So question 12 is a big one. 5 items bought at a shop are shown on the receipt. So 5 of them are shown, but there's nothing for apples. The part missing, the part showing the cost of apples is missing. How much did the apples cost? So we have the total, just need to add these together and then minus that from 590 basically. So first, obviously all the ones equal 4. So I'm just going to take that aside and I'm going to work with these. So the 2's and 2's, that gives me, or the 20's and 20's rather, that gives me a 0.40. So I'm just going to put them together. Then 0.35 and lastly 0.64. Now I know 4 and 6 already make a 1, so I can just place that there. I'll just add these two, and so I know that when I add these two I get 1.04, right? And then I can just add 35 to that, so I'll get 1.39 is what all of these are. So 4.00 plus 1.39 gives me 5.39. And then I just need to subtract that from 590. So so if I add 1 to this, this would be 5.4. And then if I add 50 to this, it would be 5.9. So 51 is my answer. And if you don't understand that, let me also do it a bit slower. So 5.9 and 5.39, right? So 5 and 5 becomes 0, 9 minus 3, well, 0 minus 9 can't happen, so we get a 1 here, right? And then that's an 8, and then 8 minus 3 is 5. So 0.51. So if I do it slowly, I just kind of did it really fast because I know that if I add 51 to 39, I'll get 90. All right, the total cost of $590 when converted to euros is 680 euros. Using these totals, draw a graph on the axes in the answer space, which will enable you to convert dollars to euros. So let's just do this in yellow first. So 590, which should be this, is equal to 680, and I think that's where it will be, because that goes up to 6. Yes, it goes up to 7. Okay, would be equal to 680. So wherever these two lines meet, which I was pretty accurate on that actually. So they will meet here, they will meet there, and then we can use that to now make our line to the middle. I kind of messed that up a little bit. Let's start from the 0 side and then just make our line. Okay, I think that's good enough, right? So that is the line that lets us now convert a dollar amount into a euro amount. So use your graph to estimate the cost of the mineral water in euros. So mineral water was 1.2. So from 1.2, if I make a line, 1.2, it is around here. And then let's drop that line down. So it would be 1.38 or 1.4. So I think I've already written 1.4 here, but yes, it would be 1.4. I think anywhere from 1.35 to 1.4 would be acceptable for this, but I think my line is actually closer to 1.4, so writing 1.4 is totally okay. All right, that is question number 12. Okay, let's do question 13. Solve the equation 5 over x plus 1 is equal to 4. So right away, I'm just going to multiply both sides by x plus 1. So that's just going to leave a 5 here and a 4x plus 4 on this side. So let's subtract 4 from both sides. So that leaves a 1 here and a 4x over here. And now we divide both sides by 4. So we get an x is equal to 1 over 4. And that is our answer for part A. Part B is solve the inequality 7 minus y is less than 9. So again, minus 7 from both sides. That leaves us with minus y, or negative y is less than 2. And then I'm going to multiply both sides by negative 1. Now, when you multiply by a negative number in an inequality, you should switch the sign of the inequality, because basically the positioning, or the reference of your inequality changes when the polarities, or when the positives and negatives of these change. So basically, just remember that if you multiply by a negative in an inequality, just flip the sign. So this becomes y is greater than minus 2. So y is greater than minus 2. And lastly, we have write down the least integer value of c for which c is greater than minus 4. So integers are just whole numbers. So like 1, 2, 3, or minus 1, minus 2, minus 3. 3.2 will not be an integer, but 3 would be. So, or that's a good way to remember, at least at this stage. So the least integer greater than minus 4 is minus 3, because it's just 1 greater than minus 4. So that's simple. All right, moving to this one. Now, this question is a little complicated, but I will try my best to explain it. Basically, the points A, B, C, D, and E lie on a circle with diameter AC. EB and AC meet at F. So EB and AC meet at F, right there. GA is a tangent, which means it makes a 90-degree angle with the line that passes through the center. And CDE is equal to 128, and BFC is equal to 65. Calculate GAE. Now we know that this is 90, so we need GAE. So for this one, this whole thing, A, C, D, and E, is a cyclic quadrilateral. Now, a cyclic quadrilateral is basically a quadrilateral formed when all the lines of the quadrilateral are actually chords in a circle. So all the lines are basically of the quadrilateral are basically lines that touch the ends of the circle. So that makes a cyclic quadrilateral. Now we know the sum of internal angles in a quadrilateral is equal to 360. We know that. Another thing that we also know is when we make an angle from a chord, so this line makes this angle, and also this line also makes this angle on the circle, right? So we know that these two angles will actually be the same. So this will be A, and this will also be A. The same thing we can do here with this line. So this line makes this will be B. Let me zoom into this. This will be B, and then this line also makes this angle, and this will also be B. Okay, so now we also have this line, and this line makes this angle. Let's call this one C, and then this line also makes this angle. Let's call this one C as well, right? And then the same, so this will be D, and this will be D. Okay, so far so good. Now, what we know is B plus C. This angle is B plus C, right? And if you notice that this down here, now if we look down here, this is a triangle. This is a triangle which has B and C as two sides. So B plus C, and then this side of the triangle, is A plus D. So if we wanted to find the overall angle of this triangle, and a triangle, then the sum of interior angles of a triangle is 180. We know that. And now we know that B plus C is equal to this angle, and it's also two sides. So can we say that A plus D is actually equal to 180 minus B plus C? So once we have that, I wrote A plus B. Let me rewrite that better. A plus D is equal to 180 minus B plus C, which is this side, right? And also these two. That means A plus D plus, if we just add B plus C on both sides, B plus C is equal to 180. Now let's come out of the reference point of the triangle and just look over here, right? Let's get rid of all of this. What we've just proven is that A plus D plus b plus c is equal to 180. And these are the opposite ends of a cyclic quadrilateral inside of a circle. These are the opposite ends of a cyclic quadrilateral, which is a quadrilateral whose all four sides touch the edges of the circle. And the opposite ends, when you add them together, they make 180. So after proving all of that, when we come back to our question, we can see that we have two opposite ends here. We have two opposite ends here. That means that these two should add up to make 180. And with that knowledge, we can do 180 minus 128, and that will give us 10 minus 8 is 2, 7 minus 2 is 5. That will give us 52 for this one. And we also know, and we already know that GAC is 90, so 90 minus 52, this 10 minus 2 is 8, and 8 minus 5 is 3, and that gives us GAE as 38. So we now have 38, which is GAE. This is 38. Okay, and now we need to find AEB. So to find AEB, we need to find this one. Well, we know that this will be the same as 65, right? And then this would be, these would be basically 65 into 2, 360, and then divide by 2. We can actually do a whole exercise to find that as well. But this will be 65. We already have 52. And then we know that a triangle makes 180. So 180 minus 65 plus 52. 65 plus 52. 5 plus 2 is 7. 117, right? So 180 minus 117. 7 minus 1 is 6. So this is going to be 63. And we have AEB is 63. Now, if you're a bit confused about me just simply saying that this is equal to 65 because these are opposites, let me also do it a little harder. Actually, I might just make a different video going through the properties of a circle to explain different properties, because there are a few different properties that people do get confused on. I think the cyclic quadrilateral was one of the more confusing ones, whereas these opposite angles being the same is a little bit less confusing, but I'll make a different video going through all the properties of a circle. But for now, that is question number 14, which is 38 and 63. Okay, let's continue on with question number 15. So the lines x plus y equals 2 and x minus 3y equals 6 are shown on the diagram in the answer space. What diagram in the answer space? I'm assuming this one. Okay, so these two lines are on that diagram. Let me zoom out just to be able to see both. All right. Find the gradient of the line x minus 3y is equal to 6. So we don't really need the diagram for this, although we could look at the diagram and figure it out. If we were to look at the diagram and figure it out, we would do x minus 3y is equal to 6. I guess either way, we're going to have to do this, which is that the general equation for a linear equation is y is equal to mx plus c, where y and x are just in the equation and m and c mean something. So m is the gradient, which we're trying to figure out, and c is the y-intercept, which is where the line cuts the y-axis. So what we're going to need to do is bring this equation in this form. So how I do that is, well, we have x minus 3y is equal to 6. We can make the x go over there by minusing x from both sides. So we'll have 6 minus x. And then we can divide both sides by -3. So y is equal to minus x plus 6 over -3. And let's split that out. So let's do, I know it says for examiners use wholly, you shouldn't write here, but this won't be going to an examiner, so I will. Okay, so we'll do minus x over -3, and we'll do plus 6 over -3. So that will just become -2, And this will just, the minuses will be cancelled, so this will just be x over 3. So x over 3 minus 2 is going to be our equation. So that tells me, so what is, so this part is c, and this part, I'm gonna write it like this part is m, this part is c, this part is m. So m is 1 over 3, which is our gradient. Now what we could have also done, if you don't know that m is the gradient, even though you've gotten it in this form, you could come down here, you can see that there's this line, which, so wait, no, that's not the correct line. It is this line, which cuts the y-intercept at -2, and you can see that this line would be this line, so you're gonna take 2 points, and you can figure out the gradient that way, which would be like, we'll take this point, and then we'll do y2 minus y1 over x2 minus x1, and I guess I can do it like this. So we'll take this as our point 1, so this is 0 and -2, and this point will be about 1, and then minus 1.8. Let's see. So 0, do this as 0, and then this is like 1.8 minus 0, and then this is, oh wait, negative 1.8 would be up here because it's y2. Okay, hold up. So that part is 0, and then minus would be a plus, so I'm just gonna write +2, and then this is, that's a 1, so 1 minus 0, and 1.8-ish, right? Or we could just take it as a 2, but yeah, 1.8, and that'll give us the gradient of like 2.8 over 1, which would be 2.8. That's not that. I'm doing something weird. I've done something weird. Let's figure out what I've done wrong. Okay, why is the gradient different here? Where is that? Unless they really don't want us to do it this way, but maybe let's take this as our point 2. So if this is our point 2, the x is 3 and the y is -1. Right, so we have -1 plus 2, so that's -2, and we have 3 minus 0, yeah, so -1 plus 2 is a 1, and then 3 minus 0 is 3, yeah, so 1 over 3, which is the gradient we got up here. So you could do it like that, where there's a possibility of mistakes, as I just demonstrated, or you could simply bring it into this form and figure out that this number is m, and that is the gradient. Okay, second part is, on the diagram in the answer space, shade the region defined by the inequalities. So one of these we've already solved. We did this one, right? X minus 3y, so we brought this in this form. This is y is equal to 1 over 3 x minus 2, right? So we know this line, and we know that y would be less than this. Actually, we'll do that again, but basically we're just gonna, okay, x plus 1 would be x plus 1 is greater than or equal to 0, which means x is greater than or equal to, if we minus 1 on both sides, x is greater than or equal to -1. So x, where is x always -1? This line. This line right here is where x is always -1, right? So x, our x, is actually greater than that, so we'll be shading to the right of this and nothing to the left of it. All right, this part is x plus y. X plus y is equal to 2. X plus y is less than or equal to 2, which means y is less than or equal to 2 minus x, right? So that is basically -1 x plus 2, right? Y is less than or equal to -1 x plus 2. So it's probably this line, because this is, and then the gradient is 1. We can see because it does 1 fall and then one rise and 1 run, right? 1 fall and 1 run. So that is that line, and y is less than that, so we're going to be shading below that line. And then the last one, even though we converted it already, I'm going to convert it again because I have a feeling something's going to happen here. So minus 3y is less than or equal to 6 minus x. And then what will happen is basically when we divide or multiply by a negative number, we flip the inequality. So we make it greater than equal to. And then we have the same thing that we figured out earlier, which is x over 3 minus 2, which is that line. So y is greater than that, so we're just going to shade this region. So above this line, below this line, and to the right of that line. And we can just shade this region, which makes a nice little triangle, and that is going to be our answer. Okay, let's do questions 16 and 17. So state the order of rotational symmetry of a regular decagon. So the order of rotational symmetry is basically how many times can you rotate a shape so that it still looks the same. Let me see if I can find a decagon here. A decagon is a 10-sided polygon. You really need to remember these, or just like know what each of the Latin numbers mean. So I think oct is 8, 8, I was about to write 9. I think like enneagon or endogon, it spells like this, like ennea is like 9, dec, where decimal comes from, is 10, right? Dec is 10, and you know, there's a bunch of them, but knowing these is really helpful. Let me see if I can find a decagon here. We have things up to an octagon. It'd be very easy to rotate if I can find it here. Otherwise, I can just draw one and rotate one. I don't think I have a decagon. All right, so let me just draw one. So 1, 2, 3, 4, 5, 6, 7, 8. That ended up being an enneagon. Hold up, I'll probably cut this part out. Here is our decagon. Here it is in all of its glory. Okay, so if I rotate it, so just keep an eye on, we'll have these two dots as our reference points so that we can see them moving. So this dot doesn't move, but that dot will move, and that way we can test it. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? And now both the dots are in their same spot. So we can rotate it 10 times, and it still keeps its shape, and rotate it like around a circle, basically 10 times. The angles don't really matter here because it's just the order. We just need to know the order. If they just asked the rotational symmetry, we would be figuring out the angle it needs to be rotated at to keep its same shape. So anyways, for decagon, that will be 10. All right, moving on. Write down those letters of the word ambulance which have a vertical axis of symmetry. So vertical means, you know, just straight line up like that. This is horizontal, this one's vertical, that one's horizontal. Okay, so what I just need to do is make straight lines through these and then see which letters look the same on both sides of the line. So B clearly doesn't, U does, L doesn't, although I messed up that line. It's not in the middle, so L doesn't. A definitely does. N is a weird one because it seems like it does, but it's not the exact same, right? These two lines are different. C doesn't and E doesn't. So the three letters will just be A, M, U. Okay, moving on. So this one's an interesting question. It says A and B are 2 points in space which are 10 centimeters apart. So let's just make a line over here. So make a line. And this is A, and this is B, and they are 10 centimeters apart. I'm gonna write centimeters, okay. Describe fully the locus of points in 3 dimensions that are 3 centimeters from the line which starts. So 3-dimensionally, every point that will be 3 centimeters from this line. So because it says 3 dimensions, we would think of it in 3 dimensions. So this would make a whole circle around, right? And that circle would extend over there, and then that would also make a circle around, right? So that would be a cylinder. But then we also need to think in this direction and in that direction. And so this would make a hemisphere here and a hemisphere here, basically making a pill shape, right? A pill shape would be formed with 2 hemispheres on the end and a cylinder in the middle, all 3 centimeters apart. Hemisphere would have a radius of 3, and so would the cylinder. So a cylinder with spherical ends that are 3 centimeter in radius. Now you could say that in a multitude of ways. You could say that in many ways. However, I'm pretty sure they would be looking for the word cylinder and hemisphere and 3 centimeter radius. Those are probably the keywords that they are looking for, because you need to describe this. All right, moving on to question number 17. A function is defined by f of x is equal to 3x plus 4. Given that f of k is equal to k, find k. So simply f of k is equal to k. So when we put k in place of x in this function, we get k. So we can just find k. So first what I'm going to do is I'm going to subtract k from both sides. So this is going to be 3k minus k plus 4, and then subtracting k from k on that side is going to be 0, and then 3k minus k is going to be 2k plus 4, it's going to be 0, and then 2k, now subtracting 4 from both sides would be minus 4, and then k would just be minus 4 over 2, which is minus 2 over 1, but basically minus 2, so k is minus 2. All right, find the inverse of f. Now, to find the inverse of a function, simply what you should do is write it as this: y is equal to 3x plus 4. 4. Exchange y and x. So basically exchange the positions of y and x, and then make y the subject. Or you could do the same, but say f of x instead of y, but make y the subject. So to make y the subject, I'm going to subtract 4 from both sides. That's going to be x minus 4 is equal to 3y, and then divide both sides by 3. That's going to be x minus 4 over 3 is equal to y, which is the inverse of our function. So f inverse of x is just going to be x minus 4 over 3. X minus 4 over 3, and that's simply how you inverse a function. We can also test this. Basically, the inverse of a function does the opposite of what a function does. So let's say if we have f of x is equal to, that's what we have, right? F of x is equal to 3x plus 4. If I find out f of 1, so 3, 1 plus 4, that's going to be 7. 3 plus 4 is 7. Basically, what the inverse does is if I put 7 into f inverse of x, I should get 1. So I can test it out right away. So if I put f inverse of 7, so in this one, if I put 7 minus 4 divided by 3, 7 minus 4 is 3, so that's 3 over 3, and that's going to give me 1, which means my inversion is correct. Basically, the inverse function gives us the input of that function, and vice versa. Okay, let's do question 18. So, in a group of language students, 24 studied Spanish, 23 studied French, and 15 studied German. 12 studied Spanish and French, 10 studied German and French, 6 studied Spanish and German, and 4 studied all 3 languages. By drawing a Venn diagram or otherwise calculate the number of students who studied. So I think in these questions, drawing a Venn diagram makes things very, very easy. So I am going to do that. So let's just have our circles there. All right. So we'll call this one Spanish, French, and German. Both Spanish and French, but not German, is what we want, the number of students who studied this. So we know this entire circle, everything in here is going to be 24. This one is going to be 23. This one is going to be 15. 12 studied Spanish, and everything inside this little area is going to be 12. German and French, so this one is going to be 10, and then Spanish and German, this one is going to be 6, and then 4 studied all 3 languages, which means this little bit here is going to be 4. So what we need to find is actually just this part, which is both Spanish and French, but not German, because 4 is, so we need to find this part without the 4, because the 4 also study German, so we just need those. So we know this whole part, which is Spanish and French, 12, who might study German as well, but 12, we know that this part has 12, which also includes the 4. So if I call this one x, we know that x plus 4 is actually equal to 12, which means x is going to be 8. So that's going to be 8, so I can just make my eraser a lot smaller and write 8 out there, right? And then the next part is probably going to make me calculate the entirety of the Venn diagram, so I probably should, because they want to know people who study only one language. So they either study only Spanish, only French, or only German, which means I need this part, and this part for this question. So for that, I'm pretty much going to have to calculate the entire Venn diagram. So this bit is French and German, which we know is going to total 10, so 4, and then if this was x, so this would be 6, because 6 plus 4 makes 10 who study French and German, and some of those might also study Spanish, but this sentence doesn't tell us that. And then Spanish and German, 6, so this would be 2, because 4 plus 2 is 6, which is people who study Spanish and German and might also study French, but this sentence particularly doesn't tell us that. And then 4 is all of them. All right, so now we know that this entire circle containing Spanish is supposed to be 24. So we already have, so this is 2 plus 8 is 10, and then plus 4 is 14. So we already have 14, and then 24, we just need to add another 10 to make that 24. That means it would be a 10 here, and now this entire circle makes 24, and then this entire circle needs to be 23, so 4 plus 6 is 10, and that's an 18. 18 plus 5 gives you a 23. That's like 2 and then 3. Yep. So this would be a 5, and then that entire circle is a 23. And then lastly, 6 plus 4 is a 10, and that makes a 12. And we know 15 total studied German, so this would just be a 3, because then if we add all these together, 3 plus 2 is 5, 4 plus 6 is 10, 5 plus 10 is 15. So this gives us the entire Venn diagram, and now we just need these numbers, which are students who only study one language. And then we add these together, so 10 plus 5 is 15, plus 3 is 18. So there are 18 students in total that only study one language. All right, moving on. The set A consists of the points whose coordinates x and y are given by this. So anything in set A would be found by this equation, where x has a value and then this equation gives us the value of y. The points in set B are given by, so these are all the points in set B, okay? And then find n of B. So this basically means the number of things in B. N of B just means how many things are in B. So we can just count that: 1, 2, 3, 4, 5. There are 5 things in B. And then now A intersection B, which means we need to find this bit, which is all the things in B that would also be in A. So how we would do that is we would take the x of this and then put it in that equation and see if it gives us the corresponding y. If it does, then it exists in set A. If it doesn't, then it doesn't. So first, if I put 0 here, 2 into 0 is 0, plus 1 is 1. That is not a 1, so that doesn't exist. And then the same thing is here, but we got a 1, so this definitely exists in there. If we put 1 in there, 2 into 1 is 2, plus 1 is a 3. That isn't a 3, so this one doesn't work. 2 into 2 is 4, plus 1 is a 5, and this is a 5, so that one is in there. And then 3 into 2 is a 6, plus 1 is a 7, but here the y is 6, so that one also doesn't work. So these two are the only ones that exist in both B and A, so we can just write them here. So 0 and 1, and 2 and 5. A good time for question number 19. The vertices of the square ABCD lie on a circle of radius r centimeters. Show that the length L centimeter of a side of the square is r square root of 2. Okay, since this is a square, we know that its corners would be 90 degrees, right? So if a line from the middle is touching this point, it would be splitting that 90 into 45 and 45 here, and a triangle, the total internal angles for triangle equal 180. So if it's 45, 45 here, that makes a 90, and then that leaves a 90 over here, right? And this makes a right angle triangle, basically, because there's a 90, sides R and L. And then, with this knowledge, we can use Pythagoras' theorem, which says a square is equal to b square plus c square, right? If the sides are a, b, and c. So our sides are r, and l. So L square is equal to r square plus r square, which also makes L square equals to 2r square, right? I'll continue over here. So since we have to explain that, we have to say AB form a right triangle with the center with the I'm terrible at writing today for some reason. I'm also gonna zoom in so I don't take up too much space. With the center with sides R L. So L squared would equal 2r squared, as I've shown before, and this, so if we make L would be equal to the square root, if we square root both sides, this would get cut here, 2r squared, this and this get cancelled, and we are left with L is equal to square root of 2r, which is what we needed to prove, right? On the side, show that the length L centimeters, the side of square is r square root of 2. Okay, by comparing the parameter of the square and the circumference of the circle, or otherwise, show that the square root of 2 is less than pi over 2. Alright, so the perimeter of the square would be L, all of those added together, so it would be 4L, and then the circumference of a circle is pi d, where d is the diameter, or 2 pi r, since the diameter is actually twice the radius, right? So we simply need to show that one is bigger than the other, basically. So by comparing the parameter of the square by this, so we know that the perimeter is is 4L, all the L's added together, and the circumference, the spelling doesn't matter as long as they understand what you're writing, is 2 pi r. We know that L is equal to this, so 4 square root of 2 r, right? And then this remains 2 pi r, right? So this will become, we just need to show that show that the square root of 2 is less than pi over 2. Right. So this, let me do this on the side before, because I feel like we're gonna do a bunch of math. So this becomes 4 pi r, or 4 square root 2r, and this becomes 2 pi r. Right, now what we can probably do is divide both sides by 2, so this becomes 2 square root of 2r, and this becomes pi r. Okay, we can divide it by 2 again. Let's divide that by 2 again, so that leaves square root of 2r, and this just leaves pi r over 2. Okay, we know that, so we know that the circumference is actually going to be bigger than the parameter, right? We know that. So we know that this side is bigger than this side, right? We know this. This side is bigger than this side. So if we now divide both sides by r, and get rid of the r from here, get rid of the r from here, leaves us with this. Oh wait, I did it. I did it wrong. Okay, hold up. The parameter isn't bigger, the circumference is bigger, so this side is smaller than this. So pretty much everything else stays the same. I just put the wrong symbol there. So this side is smaller than this side, because this side's a parameter, that side's the circumference, and you can see that too. The circumference of the circle is bigger than the parameter of the square. Well, let me get rid of that. All right, so less than, and less than. So we can reduce this too. So basically we'll divide this by 4r and divide this side by 4r. That'll get rid of the r's, right? That'll get rid of the r's, get rid of the 4, and it'll reduce to this is less than pi over 2, basically. And that proves it, essentially. I could have done this a lot neater, but sadly I am bad at staying inside lines. Okay, what kind of special numbers are the square root of 2 and pi? The special kind of numbers that they are called irrational numbers. Irrational numbers, because they go on forever, and we can't actually comprehend what their value is. Like, you can't actually tell me what like the realistic value of pi is, because it does go on forever, and the square root of 2 is similar. It's like 1.4 something something something, and it goes on forever, and we can't exactly like say that, okay, the square root of 2 equals this or pi equals this. We can only have estimations. So hence they are irrational numbers. My handwriting is terrible and I am sorry. All right, let's expand and simplify this bit. So we'll just do, you know, the sides and then the middle. Or another way is like multiply x by all 3 and then multiply -1 by all 3, and we'll get an expansion. So x multiplied by x squared is x cubed, x multiplied by x is, I didn't write cube there, x multiplied by x is x squared, and x multiplied by 1 is just an x. Then -1 multiplied by x squared is minus x squared, -1 multiplied by x is minus x, and -1 multiplied by 1 is just -1. So this and this, this and this get cancelled, so all we get is x cubed minus 1. X cubed minus 1. Cool. Okay, factorize this. So to do that, factorizing is just basically bringing it in this form, where we have our factors sort of written split like that. So to do that, we simply take out whatever is common. So 3ay plus 3by. right? So here I know that x is common, so I'll take out the x and I'll do a minus b, because when I multiply x by a, I get ax. When I multiply x by minus b, I get minus bx. And I can do the same thing here, where I can take out minus 3y, and I'll get left with a minus b. Because when I multiply minus 3y with a, I get minus 3ay, and when I multiply minus 3y with b, I get plus 3by. So we can simply have x minus 3y, a minus b. And that is our equation factorized. It's not really an equation, it doesn't equal anything. A minus b. All right. Okay, question number 21. So, two vertical posts of the same height stand on horizontal ground. The distance between the posts is d centimeters. A wire of length w centimeters is suspended between the posts. The sag in the middle is s centimeters, and the sag formula is given by this. So they've given us everything. This was kind of just a story to explain. Yeah, this would if you weren't able to read this very fast, it would take some time, and especially because like they've given us the formula, this would be kind of a question that's designed to take a student's time who might take a long time reading it. But anyways, let's continue. Find S when D is equal to 800 and W is equal to 803. So all we have to do is plug in these values in there. So let's just do that. So S here would be equal to the square root of 3 to 800, and then 803 minus 800 is just 3, and then that's divided by 800. So let me just do 3 multiplied by 3, which would be 9, and then 800, I can, because they're all being multiplied, I can just divide 800 by 8, and that would be 100. And so that leaves me with this, and knowing square root or indices, we are able to write this like this, which makes this very simple, because the square root of 9 is 3, it's also minus 3, and the square root of 100 is 10 and also minus 10. It won't really matter, but yeah, here it's going to be 30. You can take this as minus 3 and minus 10. However, usually the assumption when this is given in a question means the positive square root of whatever's in there. If you write it yourself, like if you're square rooting something yourself, you should consider the negative square root and the positive square root. But if they've given you a formula inside a question and they ask you to plug in values, then usually this symbol in the formula or in the question means the positive square root. So just something to keep in mind. So yeah, the answer is going to be 30 when D is equal to 800 and W is equal to 803. So express W in terms of D and S. So this just means make W the subject of the equation or the formula. So to do that, already I can, if I square both sides, I'll get S squared here is equal to 3D W minus D over 8, and then I can send the 8 over there by multiplying both sides by 8. So I'll do 8s squared is equal to 3d W minus D. Now I can send the 3d over there by dividing both sides by 3d, so I get 8s squared over 3d is equal to W minus D. And then lastly, I can do 8s squared 3d plus D is equal to W, and you can leave it like this, but what we can also do is multiply this 3D with this D, so we can have a nice fraction over here instead of a fraction being added to a whole number. So we'll do 3D squared, since 3D multiplied by D would be 3D squared over 3D is equal to W, and that makes W the subject of the formula. So our answer to A was 30, and our answer to B is 8s squared plus 3d squared over 3d. Lovely. Okay, so I like this question because it lets us explore some complex topics. So it is given that sine of 30 degrees is equal to 0.5 and and cos of 30 degrees is equal to 0.866. Write down the value of cos of 150. So what I've drawn here is a unit circle, which is basically a circle with radius 1. The reason we use this is so that when we're making our triangles, our hypotenuse is always 1. Because if I make a triangle, no matter where I make a triangle, if it lands on the circle, the hypotenuse would always be 1. So if I have a triangle like this, where this is 30 degrees, it's 30 degrees, the base is, let me actually complete this triangle. There we go. The base is some value of x and then some value of y, right? And then if I make a similar line going to do 150 degrees, where this would be 150 degrees, right? And if you minus 150 from 180, you get left with 30. So this is on a triangle, but over here with 30 degrees. And if we make a similar triangle here, now the base of this would be some negative value of x. It would be the same value of x, but negative here, and the y would still be positive. So with that logic, the cos of 30 over here is, so cos is CAH, right, which is adjacent over hypotenuse. Adjacent just means like the base, the one next to it, and the hypotenuse is always, in our case, the hypotenuse is always 1, so the hypotenuse is 1. So adjacent, so here our cos of 30 is x over, right, adjacent over 1. And then if we go to the other side, because we can't do cos of 150 because that would be a triangle, instead we're doing cos of 30 over here, which would be equivalent to cos of 50. We would have, so cos of 150, since we're doing cos of 30 over there, is going to be some value negative x over 1. So what that tells us is the cos of 150 is always the negative value of the cos of 30. So if the cos of 30 is this, the cos of 50 would just be 0.866. I hope that is easy to understand. Okay, going to the second part, cos of 60. So if this is a right angle triangle, this is 90, this is 30, this would be 60, right? So if we're doing cos of 60, it would be, so cos is again adjacent over hype. The adjacent for this 60 is y. So we have y over the hypotenuse, which is still 1. So it would be y over 1, right? If we we have sine of 30, right? So sine of 30 would be SOH, S-O-H, which is opposite over hypotenuse. Opposite for this is y, opposite is y, and hypotenuse is 1. Can we see that both of these are the same? So the sine of 30 is equal to the cos of 60. That means the cos of 60 is going to have the same value as the sine of 30. So hopefully that's understandable. Unit circles are something that took me a long time to understand on my own. So if it's not, I'll definitely be making videos about this on my own as well, so that it's easier to understand. There are some assumptions being made there of like the negative part. Why are we taking cos of 30 over here when we should be taking cos of 150? And so I'll probably make a video about unit circles just to elaborate on that. Okay, let's go to the second part. A triangle has sides of length 6 centimeter, 5 centimeter, and yeah, and an angle in between them that is, okay, that was a bit too much. So we'll do that. An angle in between them, that is 150. So this one seems longer. I'll just call this one 6, this one 5. The angle between them is 150. So normally when we have a triangle, let me just draw a triangle. So normally when we have a triangle, we usually have a height and we have a base. and we're easily able to say that it's, you know, half into base into height is what its area is. However, we don't really have a base or a height here. So how do we do this, right? So if we look at this side, right? If you look at this side, or this side or that side, either way, we can see this as one side of a right angle triangle, and we can take this as any angle here, but this would be 90. So what would be h? And considering one of these sides, let's call, how about I call this side b, and let's call this side something else. Let's call this side a, why not? Although it wouldn't really matter. So if I were to find h right now using this one, we could do we could use sine, we could use cos, we could use whatever, right? So let's use sine. So sine is opposite over hypotenuse again. So the opposite over hypotenuse would be, the sine of this would be sine of theta would be opposite, which is h over b. B would be a side that we have. Let's say this is side C, one of the sides that we have, right? If that is that, and then if we make h the subject of this, so we can say h is equal to b sine theta, right? So now we have a value for h without having the height. So if I take this away now, the middle part, sadly I took a lot away. Let me use a smaller eraser. If I take the middle part away now, and let's say we only have a and b, we still, and we have the angle between a and b, we still have a way to figure out the height, or we can substitute b sine theta for the height. So we can call it a half into a into b sine theta, right? Because a is still the base, I just renamed it a. B sine theta, which is basically, since this part is h, this is basically half into a into h, which is half into base into height, which is what we normally use as the formula for a area of a triangle. So now we have a new formula for the area of a triangle when we don't have a height, which is half ab sine theta, which is the angle between a and b. And using that, we can now apply it here. So we can take any as a or any as b, and we already have the angle in between them. So do half into 6 into 5, which is 30, into sine of 150. Now we can go back to our unit circle to figure out the sine of 150. So let me draw that again. I should have kept it up. So again, 150 would be all the way here, right? This would be 150. So it would have a negative value of x, a positive value of y, and then this would be 30 right here. And then on this side, I know the triangles aren't the same, but let's imagine they are. This would be a positive value of x, this would be a positive value of y, this would be 1 and 1, right? So the sine of 30 would be, since it's opposite over height, it would be y over 1. The sine of 150 on this side, even though there's a negative x, would still be y over 1 because it is still opposite over height. So we can say that the sine of 30 is equal to the sine of 150. And since they already told us what the sine of 30 is, we know that this is equal to 0.5. So half of 30 is 15, and then 15 into 0.5 is equal to 7.5. So is there an answer space? There is an answer space. All right, so let me just copy everything down there. That is a lot of zooming out. Let me just copy everything down there. So this is negative 0.866 this is 0.5, and this is 7.5 centimeters squared. Perfect. Okay, this is question number 23. We're nearing the end of the paper. So in the diagram, we have three vectors, OP, OQ, and OR. And E and F are the midpoints of PQ and QR, respectively. So express as simply as possible in terms of P and Q the vector PE. So PE is just half of PQ. So PQ, when we're figuring out vectors, it's basically so when you draw a line, you basically do the head minus the tail to figure out the vector. So the head here is OQ and the tail is OP, right? Because it's, Q is up front and then P is at the back. So this will give us PQ, right? So this is just Q, this is just P, and then half of that will basically give us PE, right? Half of PQ should give us PE. Should give us PE. There we go. I think I just zoned out there for a second, but yeah, we basically halven the length, so that gives us PE. Okay, now we want to find OE. So with OE, we can see that this OE is this, which comprises of this vector and this vector. If we add these two together, we get OE. So what OE is equal to PE plus OP, right? So we have Q, so this was PE. Let me just write that there, although there's probably an answer space. There has to be an answer space. There is an answer space. So let me just write that in the answer space so I don't lose track of it. So Q minus P over 2, and then OE is Q minus P over 2 plus another P. So that's going to be Q minus P plus 2P over 2, which is just going to end up being Q plus P over 2. So OE is going to be Q plus P over 2. And then hence write down OF. So similarly, OF would be similar, where instead of P being here, it would just be R being here, since RQ is going to be half, since RF is going to be half of RQ, and OF is just going to be OR plus RF. So we don't really need to figure it out, but we can just simply do Q plus R over 2 is going to be OF. Since we got OE, OF would be similar. So Q plus R over 2. Okay. And then finally, we need to find EF. So we now have OE and OF. So EF would be OF minus OE. So OF minus OE, we have values for both. So Q plus R over 2 minus Q plus P over 2, right? So this would just be Q and Q gets cancelled out, and it will just be R minus P over 2. This would be EF, R minus P over 2. And also, since it tells us to write two facts about EF and PR, let's just find out PR as well, which is easy. PR is just OR minus OP, which is just R minus P. So just by looking at these, we can see that this is half the length of this. So one of our facts, write down two facts about EF and PR. One of our facts is EF is half of PR. And since they're both going in the same direction, let me just draw EF as well. Since they're both going in the same direction, they are parallel lines. So we can simply say they are parallel. And that's a simple question. Vectors are sometimes difficult to understand, but it's a pretty simple topic. Okay, we're down to question number 24, which shows a speed time graph, shows the performance of a cyclist during the first 90 seconds of a race. So calculate the acceleration of the cyclist during the first 10 seconds. So this is the first 10 seconds. And the acceleration is basically the change in speed over time, or the amount of rise over the run. And if you recognize that phrase, rise over run, you would realize that this is the gradient. This is the gradient. So it's the gradient in these first 10 seconds, which if we draw a line here, we'll be able to see that this is 11. So if this part is 0, 0, this part is 11, 10, or 10, 11 rather, it would be 11 minus 0 over 10 minus 0, y2 minus y1, or just 11 over 10, which is 1.1. So the acceleration for the first 10 seconds would just be 1.1. Okay, calculate the distance in meters traveled by the cyclist in the first 90 seconds. Now the distance is speed into time. So if we multiply speed and time here, we'll see that what we're getting is actually the area under the line in the graph. That's how you get the distance in a graph form like this. So we can do this in segments. So this first part is a triangle with base 10 and height 11. So half into base into height would be 5 into 11, which is 55. So I'll just write that there. I don't need to do any calculations for this. The second part is I think you call this a parallelogram, right? Where you have the half into base into sum of parallel sides as its area. So the base here is 30, so half into 30 is 15. So half into 30 is 15, right? And then the sum of parallel sides, so this is 11 and this is 13 over here. I should have used a different color for these lines, but this is 13 over here. So if we add up 11 and 13, we get 24. So half into base into the sum of parallel sides would be 24 into 15. So 5 fours are 20. 5 twos are 10, 11, 12, and then a 0, 4, 2, 0, 6, 3. So that would be 55 plus 360. And then the last part is just a square with height 13 and base 50. 40 to 90 is 50. So we'll do another 13 into 50. You can just add a 0 there. So 5 threes are 15 and 5 ones are 5 plus 1, that's a 6. So that is 650. Now 3 plus 6 is, so 900 plus 110, that would be 1010 plus 55 would be 1065 would be the distance in the first 90 seconds. I hope that was easy to understand. I didn't write them out, the numbers, but I did sort of do it graphically. Calculate the time taken for the cyclist to travel 1 kilometer. So in the 90 seconds, he traveled 1065, which is just 65 more than 1 kilometer. So if we just minus 65, distance, then we can find the time minus whatever time it took, from the whole time. If we minus whatever time it took to travel 65, we'll get the time for 1000 meters, which is 1 kilometer. And since the speed in this last part is constant, we know that when you have a constant speed, distance is equal to speed into time. Speed here is constant of 13. Speed is constant of 13. Our distance is 65, and we're trying to find the time. The time will just be 65 divided by 13, which is 5. So if we just take away 5 seconds from the 90 seconds, so like here, we have 85 seconds, which is when the cyclist reached 1 kilometer. So 85 seconds. And if we actually want to show that as well, this bit, just the area of this bit would be 65. All right, easy question. Let's move on. So we have the final question of the paper. which is the numbers of goals scored in 20 football matches were these. Complete the table in the answer space. So the middle part is just so we can tally, so it's easier. So 0, we have 1, 2, 3, 4. So 1, 2, 3, 4, and the frequency of that is 4. Then 1, we have 1, 2, and then no others. So 1, 2 here. All right, 2 appears, there's a 2. So 2 appears once. 3 appears, there's a 3, and there's another 3. So 1, 2, and there's a 3. All right, and then 4 appears 1, 2, 3. 4 appears 3 times, so that's a 3. And then lastly, 5 appears 1, 2. Wait, does 4 appear 3 times? Yeah, 4 does appear 3 times. Okay, 5 appears 1, 2, 3, 4, 5, 6, 7, 8. 5 appears 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. 5 appears 8 times. And that gives us a total of 20 matches. All right, using the axis in the answer space, represent the information as a bar chart. So a bar chart is different from a histogram because the bars are not connected. So first, we would have so we'll write 0. We need to make sure the bars are not connected. So I'll actually, and you usually write it in the middle for the bar chart. So we'll do 0, 1, I'll leave a gap, 2, leave a gap, 3, leave a gap, 4, and leave a gap, 5. All right, how many times were 0 goals done? They were done 4 times. So we'll do 4. I should use my line tool. So we'll do 4. And that'll be our bar for 0. Then 1 was 2 times. So we'll do 2. Okay, 2 was 1 time. 2 was 1 time. 3 was 3, 3, and 8. All right, so 3, 3, and 8. We'll do that, and that line, and that line. My line for 3 is crooked, but let me just correct that. 3, 3, and 8, and that is our bar chart. Again, remember, the numbers are in the middle and they're disconnected. They shouldn't be connected. Also, their width should be the same because having variable widths means other things. All right, state the median. So the median, because 20 is an even number, the median would be the average of the 10th and the 11th value. So it would be the 10th value and the 11th value divided by 2. So 10th value would be, so 4 values here, 5, 6, 7, 8, 9, 10. So 10th value would be 3 and 11th value would be 4. So 3 plus 4 divided by 2 is 7, so that is 3.5. That would be our median, would be 3.5. And then the mean, which is calculate the mean number of goals, which is part C, we need the cumulative frequencies. So 4 times 0 is 0, 2 times 1 is 2, 1 times 2 is 2, 3 times 3 is 9, 3 times 4 is 12, and 8 times 5 is 40. And now I add all of these together. 2 plus 2, 4. 4 plus 12 is 16. 16 plus 9 is 25. 25 plus 40 is 65. So 65. I realized I made a mistake here, and that kind of threw off this entire question. I had the tally here for 3 was 2, but I wrote 3 over here. So this is 2. This will throw off the entire thing. So let me just really quickly correct this. So 2 into 3 is 6. This would be 12, and then this would again be 40, right? So this is going to throw off the entire thing. which means this is also incorrect. Let me fix that. So this is 2, and then that's going to change what our median is as well. The median is still the 10th and 11th value, but the 10th value will now be 4, 5, 6, 7, 8, 9. So 10th and 11th value will both be 4, so it would be 4 plus 4 divided by 2, which is still 4. So our median would be 4, because it would be 4 plus 4 divided by 2, which is 4. 8 divided by 2 is 4. And then our mean would also be different, because our mean would be, when I add all of these up, so 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 12 is 22, and then this would be 62, right? 62. So it would be 62 divided by 20. And again, I can simplify this. 2 3s are 6, 2 1s are 2, and then 2 10s, and then this would be 3.1. So this is what the correct answers are. And again, like I said before, good luck with your paper. Thank you for watching. Please don't forget to like and subscribe, and I'll keep posting these, and I will keep making these, and obviously I'll make other videos that to go over topics that are more complex, but I also like doing these and basically helping people who might want to follow along, do a paper, and figure out the explanations for things. So thank you so much again if you've made it this far, and I'll see you next time. Bye.